Hi guys, in this video we are going to discuss the educational code forces round 149 that was rated for Dev 2. So we'll be going through the first four problems, that is Grasshopper on a line, comparison string, best binary string and bracket coloring. So let's get started. The very first problem and the second problem are a bit easier. After that, problem C and D are also kind of easier, not that tough, but yeah, it's fine. So we'll be discussing all of them in detail. So the very first problem states that I'll not be going through the gibberish, but what it actually states is that you're standing at the point 0, 0, or you can, it's just a one-dimensional line. So you can say you're standing at the point 0 and you have to reach a point X, right? And you can make a jump of n number of steps that needs to be in the range of minus 10 to the power 9 to 10 to the power 9, but it should not be divisible by K, right? So that's the only criteria. And you have to tell that how many number of jumps would be required. Or in other words, I can say that firstly you have to minimize the number of jumps required, and then you have to state that what kind of jumps you are going to use. So for example, over here you had to reach the point 10, right? And your K was set to 2. Now, if in a single jump you went from 0 to 10, so you would have made a jump of 10 units, but 10 was since divisible by 2, hence you can't make it. And thereby they made two jumps, one of 7, one of 3, which was not divisible by 2. So what's the generic way of doing it? Because over here we could have seen that, okay, 10, we have a 10, so we can do it in 7 and 3, but is there a generic way of doing it? Yes, there is. So the very basic way of doing it is that since we have to go from 0 to X, let's just change the color. Okay. Since we have to go from 0 to X and we want that our jump modulus K should not be equal to 0. So what we can do is that firstly we can check that whether this X unit, if it's actually having, if it's actually divisible by K, then we can simply make a jump of, let's say, X minus 1. Now since X was divisible by K, X minus 1 won't be divisible by K. That's basic mathematics. And then we can make a jump of 1 unit. So we'll combine them to reach X. So that's pretty basic. The code also is basic. So we just have to do this, that if, okay, so I've not taken X and K, I've rather taken N and M. If your N is divisible by M, then you have to make two jumps, one of N minus 1 units and one of 1 unit, right? Else you will have to make a single jump of N units. Cool. So with that, let's move to the next problem. That is, yep, comparison string. So what the problem states is that we are given a string which either contains this less than sign or then greater than sign, right? Okay. And then what we have to do is that corresponding to this, so let's say this is a string of n characters, then we have to print, we have to construct an array of n plus 1 characters of n plus 1 integers, which should actually follow this inequality. So what do they mean by this? So for example, if this is the array that we consider, so the first character over here is less than, so yeah, 1 is less than 2. The second is less than, so yeah, 2 is less than 5. The third is greater than, so yeah, that's also correct. 5 is greater than 4, and so is, and the last character is also greater than, 4 is greater than 2, right? So this is the way we have to create the string, but we have to minimize the total number of elements in this particular array. And when I say elements, I mean the unique elements. For example, in this, there are 4 unique elements. So 1, 2, 5 and 4, because 2 is getting repeated twice. So it doesn't have 5 unique elements. Yes, it has 5 elements in total, but the unique elements are only 4, right? So with that information, how can we do it? So there are multiple ways of doing it. One of the ways was actually binary search, but it's way too complicated and not required. So I'll be talking of a pretty easy one. So the basic fundamental is, or the basic idea for this particular problem is that if you are having this less than signs, right, then whatever value you are putting over here, let's say I put a value y over here and the value over here was x, right? Then obviously my x is less than y, that has to follow. So the least value that I can give to y would be x plus 1, because they have to be integers, right? So the least value of y would be x plus 1. Now what would be the most value of y? That could be actually anything, right? It could be infinity, because even infinity is greater than x. So that could follow, but I don't know about the biggest value of y possible. So it would obviously make sense, because I want to conserve the range. Why do I want to conserve the range? The simple reason is that I need the minimum number of unique elements, right? Unique elements. Now in an array, if I have an increasing slope, I have a decreasing slope, increasing, decreasing, increasing, decreasing, so on and so forth. I obviously want this range should be minimized, right? This range should be minimized. If this is the range, this is the range, this is the range, then the total range, when I take a combined value, this would be the total range, right? This is the lower point and this is the upper point. So this entire range is what I have. I want to minimize this, correct? So obviously when I'm going further, so I would like to have the minimum element for y, but would this scenario ever change? So is this one scenario where it would change. Now, for example, over here you are having y. Now let's say over here you are having z, and over here you are having something like maybe z2, just giving random names, or let's say theta, right? So what would actually happen is that you'll want that your theta should be maximized. Now, why is that the case? The theta should be maximized so that let's say you already know that the value, let's just give some random values over here. Let's call this 1, let's call this 2, let's call this 3. And we want that our range should be in the area of 1 to 10. Just giving an example, right? So over here, if you write a 4, right, then this thing would start going to negative. In order to avoid that, what you can do? Now you can say, I'll not write 4 over here, rather I'll write the maximum value. Right? That could be anything that you're not sure about, right? So how would you compute this maximum value? The matter of fact is we won't actually. It's not even required, because in the problem we don't need to state the vector or the array that we are going to produce. We just need to state the minimum number of distinct elements, right? So over here I'm not going to produce anything, but I'm going to assume that this is an infinitely large number. Right? If I assume that, then I can say that the element just to the left of it, that needs to be smaller than that, could be anything, because if it's infinite, then I have infinite choices for it as well, right? So I can put any number to the right of it, and similarly to the element just right of it, similar to the element just right of it, so on and so forth. Now what this enables me to do is that in a sequences of less than or equal to, if in a sequences of similar characters, I just need, let's say these have maybe like y characters in total. So for these y characters, I only need y plus 1 elements. Right. Now let's say our entire string is made up of so many pockets. So we have some less than, we have some greater than, then some less than maybe, then some greater than. So answer would just be the size of the pocket plus 2, or the size of the pocket plus 1. So for example, over here the number of elements are 1, 2, 3, 4. So the size of the pocket is 4 plus 1 is 5. 1, 2, 3, 4. 4 plus 1 is 5. 1, 2, 3, 4. 3 plus 1 is 4. And 1, 2, 3, 4, 5, 6. So 6 plus 1 is 7, right? So our answer technically would become 7. So I just need to count the number of pockets, and I need to print the maximum pocket plus 1. So let's look at the implementation. Yeah, here's the implementation for the same. So I'm just calculating if the current element is similar to the last element. If it's so, I'm increasing it. Else I'm setting the value to 1 plus 1, or I know that the value has to be the value actually has to be 1. 1 is for the current index which I'm at. So for that index, I need a value, right? And on top of that, as we said, that the plus 1 would be added, because 2 elements would be there, right? So 1 to the left of operator and 1 to the right of operator. So I'll initialize it with 2. And in each iteration, I'll keep updating my result with the maximum of whatever value it has, or the current value we are having, and we'll print it. So if I run this, yep, this works fine. And yeah, that's the solution. Let's move to the next problem, that is best binary string. Okay. So this problem states that we are given a string S consisting of characters 0, 1 or question mark, right? Let's call it pattern. Fair enough. Now what we have to do is that we have to put ones or zeros in terms of the question mark, right? So we have a question mark over here. Instead of this, we need to put either a 0, either a 1, right? After that, we'll be having a fixed string. Now what do I mean by fixed? In that string, we won't be having a question mark, right? So over there, we cannot manipulate it further. So we'll be having a fixed string. Now that string we need to make sorted. Now how would we make that string sorted? The basic way of making that string sorted would be that we can pick any substring and then we can reverse it. Now for example, let's say, okay, have they given an example? Yep. This is one example they have given. Okay. For example, this is the string we have, that is 10100. If we reverse it, we get a 0101, right? If we reverse this entire string, so yeah, 2 zeros come first, then a 1, then a 0, then a 1. After that, what I can do is I can reverse these two elements. Now this would become 0 1. As soon as I do it, it actually becomes a sorted string, right? So this is what I get. Cool. Now the number of operations where I had to reverse it is actually counted, and we need to minimize that. But the beauty of this problem is that we aren't asked the number of operations required, right? We are rather asked to print the substring or print the string by replacing all this question mark that would have the lowest number of moves. Cool. Now, how is that important? That is important because our effort actually reduces, because we are not even concerned about calculating the number of reverse move required. We can just do it greedily. How can we do it greedily? That's the next problem. So since if we are gonna reverse a string, right? So if we're gonna reverse a string of size 1 or 2 or 3 or 4 or n, right? In each of this scenario, the cost is 1 actually, right? So if you have a string 1 0 1 0 0 0 0, no matter if you reverse this much or if you reverse the entire string or just a part of it, the cost of that particular operation would only be 1 units. So this becomes an important point, because if you are having an element that is, let's say 1, and currently you are at a question mark, right? Then it always would make sense for you to make your question mark that is equal to the element to the left of you, may it be a 1 or may it be a 0. Now how can I say that? The reason being that, let's say if this 1 is not in its correct place, so then obviously it has to move to its right, because when we are going to sort the string, all the ones are going to move to its right. So when we are going to reverse it, so the only operation is obviously reversing the string. So whenever we are going to reverse it, we can always consider this particular element. Okay, let's just change the color to explain a bit better. Okay, so whenever we're going to reverse it, this particular element, whenever it's going to reverse, I'm also going to consider this as a part of it, right? So this is also going to get reversed along with it. Now let's, so obviously if it's 1, then it's great for me because I just need a continuity of 1s. So if this is the 1, okay, so if this is the 1, right? And this is the question mark that I made 1, right? So even this string would be sorted, right? Now what if the other case arises and this is a 0 and this is a question mark, right? The only case where it would need to be sorted is that if we want to move it to the left of it, right? If we want to move to the left of it, then I can say that, okay, these are in a pair. Make sense? And I'll move it along with it. So cool enough. So that's fine. But now one case actually remains. So the case that actually remains is that what if the string itself starts with a question mark? Then in that case, what would happen? If a string actually starts with a question mark, it's always better to replace it with a 0. That's a bold claim I'm making. And the simple reason is that if it's a 0, then I'd never need to, I'll say that this particular string, so let's say these are some x's, right? And there's a 0 over here, right? So I'll say that this much string is already sorted. So I'll just consider the remaining part of the string, right? So this would always remain sorted. Cool. So that's the intuition. And let's look at the code. The code is also small and simple. So to be honest, this is not the code I coded for the contest. I actually coded up a pretty big version. That was actually not required, but that's the first thing that came to my mind. Okay. So firstly, what I'm doing is that if the first character is a question mark, then I'm making it a 0, right? After that, whenever I'm experiencing a question mark, I'm setting it to the element to the left of it. And that's it. That's all you need to do. I think the proof I gave was pretty clear. And that's how you'll be able to print S. And like at the end, just print S, because you have replaced all the question marks with the valid characters with 0s or 1s, and hence it will always be valid. Cool. So that's the solution. And let's move to the next problem now. That is the problem D. Problem D is most of the time difficult. This time it was kind of easy. You can see like 3,000 people have already done it. So it's not that tough. So the problem, although I did a wrong submission, that was because of my own foolishness, but it's not a tough problem. So the problem D states that you are given with a string that is composed of 2 characters that could either be a opening bracket or a closing bracket. And then they have given the definition of a regular sequence. You can check it out if you want to. I'm not going through that. Now what they want is that the sequence should be beautiful. Now how would we make a sequence beautiful? So what we can do is that we can color some of the sequences, right? So okay, so Firstly, they're saying that the bracket sequence is called beautiful if one of the conditions is satisfied. It is a regular bracket sequence, right? So just read the definition if you want to. And the second condition is that the order of the characters in the sequence is reversed. If we're going to reverse it, right, then it becomes a regular sequence. If any of these two conditions are followed, then the string is beautiful. Then the bracket sequence is beautiful, right? Now what we have to do is that we have to color this sequence or these brackets in such a manner that when we take individual colors into consideration. For example, let's just take this example. So over here in this particular string, we said that we are going to color the first three elements with a color of type 2. Okay. Then this element is colored with a color of type 1, right? And then these three elements are colored with a type 3 or type 2, sorry, these three elements, right? So technically you are having first of 3 opening brackets and then 3 closing brackets, correct? And this forms a valid sequence. What about this remaining one? So you still have a closing bracket and then opening bracket, which is of type 1 color. If you look at it, so this is, okay, so this is of the type, okay, so pencil is not working, never mind. Okay, so this particular expression is of type a closing bracket comes first and opening bracket comes thereafter, right? However, the question states that if we are able to get the original a valid sequence even by reading it from the right hand side or by reversing it, even then it's a valid sequence. Now if I reverse it, I actually get a opening bracket first and a closing bracket later, right? So this is of type 1, right? So this is valid. Okay, let's go to that. Yeah, this is of type 1, this is valid, and the bracket that was coded with the type 2 was actually type 2 was 3 opening brackets, right, followed by 3 closing brackets. So this is also valid and this is also valid. So this is what we have to do. We have to print the number of colors required, and we have to then print the actual colors that we are going to give them. Now, even if over here we had mentioned 111 followed by a 2, then 111, then a 2, that would have been valid. In my case, I was printing it a bit different. So this is what I was printing. That is 222 followed by a 1. Okay, let's just refresh it. That's not what I was printing. Let's refresh it. Yeah. So I was printing all ones followed by 2 2s. Now let's see how that makes sense. So my solution comes out to be, okay, let's see. So this is what they have given. So that is triple opening tags, right, followed by 4 closing tags followed by opening tag, right? So what my algo says is that I'm going to consider all the first 5 all the first that's 1 2 3 4 5 6, yeah, all the first 6 characters as a part of the type 1 color. So this is what I get as a part of the type 1 color, right, followed by this, that is a part that is of type 2 color, right? This is a valid sequence, this is a valid sequence, and hence the answer is valid. So either we have to come up with the answer. Now how can we do it? Let's firstly go with the basics. So if you don't have equal number of closing bracket and equal number of opening brackets, in that case the answer definitely does not exist, right? So firstly, let's just check that if your C1, that is the count of opening brackets, is not equal to the count of closing brackets, then your answer does not exist. So let's just print -1. For example, over here the opening brackets are 2, the closing bracket is just 1, right? So print a -1. Then what I'm gonna do is, since over here we said that okay, a reverse pattern is also allowed, right? So it could be the case that only a single character, only single color is required. For example, if you are given with a string this, then only a single color is required, right? Because you can print the entire string with the single color and it would be valid. Or if you are given with a string something of this sorts, then also it's valid. So let's just check that out, because if that is happening, then we just need a single color. So for that, what I've done is I've made a string rs, that is the reverse of s, and I'm checking if they're already valid, right? So this is the valid, this is the simple code of checking if your string is a regular bracket, if your brackets are arranged in a regular fashion. If they are, then return a 1, else return a 0. I'm not going to go through this code. This is fairly simple. It just checks that if you're having an opening tag, then increment your open. If you're having a closing tag, then you just need to check. If your open is greater than 0, then you can pair them up. If it's not greater than 0, then there's no way you can pair them up. You have to return a 0, right? So if this is valid, then I'll print only one color is required. And for all the elements, that is the n elements, I can just print a 1, right? And I'll return. But now we can say that it's not good enough, right? So what we need to do now, what I'll do is, if it's not good enough, that basically means this entire string would be some combination of this kind of a sequence wherein you are considering the string from left to right, and this kind of a sequence wherein you are considering this string from right to left, right? Because had it been a single scenario, had it been of type 1 or of type 2, we would have simply got the answer. But since we have reached this point, that means it's obviously a combination of both of these two, right? So what I'll do is, I'll just check what all elements need to go in the type 1 sequence. So over here, what I'm doing is that if you're having an open bracket, then just save its index into the set, right? This is the set I'm having. Just let's save this index into the set. If you're not having this opening bracket, so definitely you'll be having a closing bracket. If that is the case, so that would only happen in case if your set has some elements, right? If that is happening, then for both these elements, so let's say this particular opening tag or opening bracket occurred at a position maybe like 5th or 4th index, right? And it's possible that now your I is maybe at the 10th index. So both these 4th and 10th index would be paired up. So basically both of these indices or both of these elements should have the same color. So we'll say whatever element is at the top, that would be the 4th index, right? So let's paint them 1. And whatever element is at the 10th index, that is the ith index, let's paint them 1 also, right? Now I'm painting 1 over here because initially I'm giving them a value 2. I could have done the opposite, but it doesn't matter. You can do anything. So we'll paint both of these as 1, 1, right? And I'll pop it because now this element, that is the 4th element that was initially pushed onto the stack, is actually empty, is actually utilized via 10, right? Cool. And after doing this, the answer would definitely be there in result because initially it was set to 2. So all of the elements were colored with 2. And now after this procedure, some of the elements would be colored by 1, right? So yeah, that's it. So you'll print 2 followed by the resultant array. And this is a valid answer. I know it's showing failed over here. The reason being that multiple answers are correct. So even this is correct and this is correct, but the system isn't intelligent enough, so it discards it. Fine, that's the solution. And if you want a reasoning for why there would the answer would always be max 2, the simple reasoning is that either your string is going to be of type 1, that is read from left to right, or it's going to be of type 2, that is from right to left. However, if it's not of neither of these types, it has to be a combination of these two, right? So you can definitely put some of the elements in type 1 and some of the elements in type 2 and get a valid scenario. So yeah, that's the solution for this. I hope you understood all the problems. If you still have any doubts, let me know in the comment section below. Cool guys, thanks a lot for watching this video. Bye bye.